Welcome to the deep dive. Let's just jump right in because I think this will hit home for anyone who feels like they're drowning in information. Think about biomedical research.
Oh, yeah.
The sheer amount published daily. I mean, PubMed alone sees thousands of new articles every
Yeah.
single day.
Staggering, right.
Exactly. So the big question is, how does anyone, a researcher or a doctor,
Yeah.
actually stay informed, properly informed, without just getting completely buried?
Well, that feeling, that precise sense of being overwhelmed, that was really the spark for what we're talking about today, Askle.
Askle. Okay.
Yeah. You can think of it as an AI research assistant. It's built using Google's Gemini models. Their capabilities are pretty incredible.
Right.
And the main goal is, well, simple, but also quite powerful.
Yeah.
Get trustworthy, really up-to-date answers to specific biomedical questions, but crucially, without all that manual digging through endless papers.
So it's like a shortcut to the relevant info.
Kind of, yeah. Making that critical knowledge accessible, fast.
And what's really interesting for this deep dive, I think, is we're not just looking at Askle as like this finished product off the shelf.
No, definitely not.
We're actually going behind the curtain a bit.
Hmm.
We'll look at how it was built, maybe touch on some of the code involved, and really focus on how Google Gemini, its power, made this whole thing possible.
Exactly. It's the story of building Askle, really. That's the focus.
Yeah. Okay. So let's start with the why. Why build Askle in the first place? We touched on the info overload.
Right. That's the core problem. The sheer volume of published research, and it just keeps growing. It's a massive hurdle. If you're a biomedical professional, a researcher, anyone in that space, keeping up with the latest findings, the new clinical guidelines, figuring out what the expert consensus actually is, it feels endless.
Yeah, I can imagine.
So Askle was designed specifically for that, a way to get quick, synthesized information you can actually use.
And how does it work at its core? What's the main function?
Okay, so you ask it a question, a specific medical question, maybe about treatments or the genetics behind a disease, whatever.
Right.
And Askle goes to work to give you a comprehensive answer. But, and this is key, it's not just some random AI hallucination.
No, you definitely don't want that in medicine.
Absolutely not. The answer is built using the latest scientific literature, established clinical guidelines, expert consensus docs, and it always tells you where it's getting information. References are crucial.
Okay, that referencing part sounds really important. How is it structured to actually achieve that?
It's built in 4 main phases, a modular design, which is quite handy.
4 phases. Okay.
First is query understanding and retrieval, basically figuring out what you actually asked and where to look.
Makes sense.
Second, data acquisition and storage. So finding and grabbing the relevant stuff, abstracts, guidelines, that sort of thing.
Got it.
Third phase is RAG indexing and embedding. RAG stands for Retrieval Augmented Generation. It's about making the collected info smart and searchable for the AI.
ARGI. Okay, we'll probably dig into that more.
We will. And finally, phase 4, answer synthesis and referencing, taking everything it's gathered and processed and, well, writing the answer with those all-important references.
And you said modular.
Yeah, that modularity helps a lot, makes it easier to improve or add new features down the line. More developer-friendly, you could say.
Okay, let's break down that first phase then. Query understanding. You mentioned Gemini's involved right from the start.
Oh yeah, heavily. This is where we use a couple of really powerful Gemini features. One is called few-shot prompting.
Few-shot prompting.
It's like giving Gemini just a few examples of what you want it to do. So for Askle, we show it examples of user questions and the important keywords we want pulled out for searching.
Ah, so you're teaching it by example.
Exactly. Just a few examples are usually enough. And we combine that with Gemini's ability to produce structured output. Specifically, we ask for JSON format.
JSON. So like machine-readable data.
Precisely. Makes
Yeah.
it super easy for the next part of the system to use those keywords.
And there's even some code related to this, right? Like a prompt that tells Gemini what to do.
Yeah, basically the prompt says something like, you're an expert at picking out biomedical search keywords. Take this question and give me back a JSON object. Just the keywords in a list.
And you give it examples.
Right. Like, if the input is, what are the latest treatments for rheumatoid arthritis?
Yeah.
The output it should generate is that JSON structure. Keywords, latest treatments, rheumatoid arthritis.
Clever. So when my messy real-world question comes in, it knows exactly how to pull out the useful bits.
That's the idea. And for this, speed is pretty important, so we're using the Gemini 2.0 Flash model. Gets the job done quickly.
Okay, so Askle understands the question. It has the keywords. What's next? Phase 2.
Phase 2, data acquisition and storage. Now it needs to find the actual information. Primarily, that means searching PubMed using those keywords. It looks for relevant journal abstracts, clinical guidelines.
And how does it get that data? Does it just scrape PubMed?
It uses another Gemini feature here called function calling.
Function call.
Yeah. It lets us tell Gemini, okay, you found this search result with a link. Now go download the literature from that URL. Gemini can trigger that action for us.
Whoa, okay, so the AI can actually do things, not just process text.
Exactly. And then there's also document understanding. Once it has the abstract, or maybe even a full PDF,
Right.
it needs to parse it, understand the structure, pull out the key information. Gemini helps with that too.
And this data gets stored somewhere. You mentioned storage.
Yep. We use a simple SQLite database for this.
Yeah.
In the code, you'd see it setting up a database, maybe called pubmedpapers.db, and creating a table, like a papers table, to store the details it downloads.
So Askle is basically building its own little focused library for my specific question.
That's a great way to put it, a temporary focused library.
Okay, library built. Now, how does Askle make sense of all that text? That sounds like the tricky part. Phase 3.
Phase 3, RAG indexing and embedding.
Yeah.
And you're right, this is where some really cool AI stuff happens. We use Gemini's embedding model here.
Embedding model, what does that do?
Essentially, it reads the text from all those abstracts and papers and converts it into lists of numbers vectors. These are called vector embeddings.
Numbers. Why numbers?
Because these numbers, these vectors, capture the meaning of the text, the semantics. It allows the AI to understand how different pieces of information are related, even if they use different words.
Ah, okay. So it's like translating the concepts into a language the AI understands.
Exactly. A mathematical language based on meaning.
And where do these embeddings live?
They need a special kind of database, a vector database. We're using ChromeDB for Askle.
ChromeDB?
Yeah, it's really efficient at storing these vectors and finding the ones that are most similar, most relevant to your original query, which has also been turned into a vector.
I see. So it searches based on meaning, not just keywords.
Right. And the code shows ChromeDB being set up in persistent mode. That means the knowledge base Askle builds can actually be saved and potentially reused. There's a function mentioned, process papers for RAG persistent, which handles adding the paper embeddings to this database.
Okay, this is starting to paint a picture. We've understood the query, got the data, made it searchable by meaning. What's the final step? Phase 4.
Phase 4, answer synthesis and referencing. Now we pull it all together. Askle takes the most relevant chunks of information, identified by that RAG search in ChromeDB.
The most relevant vectors, you mean?
Well, the text associated with the most relevant vectors, yes. And it puts all of that, plus the original query, into one big prompt for Gemini.
A big prompt. How big?
Potentially quite big. And this is where another key Gemini feature comes in. Its long context window. It can handle a huge amount of text in one go.
So it can see all the relevant evidence at once.
Precisely. And based on all that input, Gemini then synthesizes the final answer. A coherent, readable answer to your question. And crucially, it includes those numbered references back to the source documents.
And the code shows this final step.
Yeah, you'd see something like client.models.generate content being called, feeding it that big prompt and getting the final answer back.
Wow. It's really impressive how all these different AI concepts, the kind you might learn about in, say, Google's Gen AI course, are actually wired together here.
Absolutely. If you look at the list, Askle uses quite a few. Structured output for keywords, few-shot prompting for query clarification.
Document understanding for parsing the papers.
Function, calling for downloading, that long context window for putting it all together. The embeddings from Gemini's model.
Vector search with ChromeDB. Grounding to ensure the references are solid. Even Gen AI evaluation, like recording ratings for the answers.
Yeah, it touches on a lot. And it's interesting to see what's marked as in progress, like using AI agents for more complex workflows.
Or not yet implemented. Things like understanding images or videos or proper MLOps for managing the whole thing shows the potential growth.
Definitely.
Could we walk through a quick example, maybe that messy query you mentioned earlier?
Sure. Let's take that garbled input. What's the hashtag $52 using Belos at and therapy for non-small lung cancer?
Right. Looks like someone typed in a hurry.
First step, Askle, using Gemini, cleans it up. What is the first-line therapy for non-small cell lung cancer? Much clearer.
Okay.
Then, phase 1 extracts the keywords using that few-shot prompting and JSON output. First-line therapy, non-small cell lung cancer.
Got it.
Phase 2 uses those keywords to search PubMed. It might do searches for both recent papers and highly relevant papers,
Yeah.
maybe grabbing the top 5 of each. It downloads the abstracts, maybe tries for full PDFs using function calling.
Hmm.
Phase 3 processes all that text, plus maybe some preloaded guidelines, turns it into embeddings, stores them in ChromeDB,
The right part.
the right part. Then phase 4 takes the original query vector, finds the most similar document chunks in ChromeDB, puts them all into the long context prompt.
And asks Gemini to write the answer.
Exactly. Synthesizes a grounded, referenced answer based on everything it found.
Yep.
We don't have the exact answer text here, but that's the flow.
That makes the process much clearer. I mentioned specific libraries underpinning this.
Yeah, a few key Python libraries make this work. Obviously, Google Gemini is essential for talking to the Gemini models.
Right, the core engine.
Chromab for the vector database part.
Yeah.
Squite3 for that local database storing paper info.
Okay.
Then there's BioPython, specifically its onTrez module, which is really useful for interacting with PubMed programmatically.
Ah, for the searching.
Exactly. And libraries like FIS might be used for handling PDF files and requests for fetching things from URLs generally. They all play their part.
It really drives home how central Google Gemini is to this whole thing, doesn't it?
Absolutely. That huge context window is a game changer for synthesis. The advanced reasoning allows it to do more than just summarize. It can actually connect ideas from different sources.
And those API features you mentioned.
Function calling, structured output.
Yeah.
They're not just nice-to-haves. They were pretty instrumental in making Askle practical to build. They allow the different stages to talk to each other smoothly. Gemini's understanding and generation capabilities are really the heart of it.
So what are the big benefits then for a researcher or a clinician using something like Askle?
Well, the most obvious one is time saving. Potentially hours saved compared to manual searching and reading.
Huge.
Getting quick answers that are actually based on evidence. And there's a potential cost benefit too, because a lot of the heavy lifting is done via the Gemini API interacting with locally stored or freely accessed data. It might scale more affordably than systems relying constantly on expensive external databases.
Interesting point on scalability. Okay, so let's sort of recap. Askle, built using Google Gemini, tackles that massive biomedical information overload problem.
Right. Uses that four-phase design, understanding the query, getting the data, indexing it with ARG, synthesizing the answer.
And leverages a whole suite of Gemini's features to make it happen, acting like an AI research assistant.
That's the essence of it.
But it's not perfect yet, right? What are the current limitations or challenges?
There are definitely things to work on. API rate limits can be a factor.
Yeah.
Getting access to the full text of paywalled articles is often a challenge.
Yeah, that's a big one.
And ensuring the grounding, the referencing is perfect in every edge case takes ongoing refinement. But the future potential is really exciting.
Like what? What's next for tools like this?
Well, imagine adding image and video understanding. Think radiology reports, pathology slides,
Wow.
or making the AI more agentic, able to perform more complex multi-step research tasks autonomously.
Mhm.
And integrating proper MLOps practices for continuous learning and deployment. Lots of possibilities.
It really makes you think about how AI like this could change research, not just in biomedicine, but, well, everywhere.
It's a paradigm shift, potentially.
And for listeners who are maybe developers or just really curious, you mentioned the code.
Yes, we're planning to release Askle as an open source project on GitHub soon, so people can dig in, see how it works, maybe even contribute.
That's fantastic. We'll definitely share details on how people can find that and also how they can connect maybe on LinkedIn to share thoughts or questions.
Please do. We'd love to hear feedback and ideas.
So maybe the final thought to leave people with is this. The landscape of research is changing fast. And AI, like we've seen with Askle powered by Gemini, isn't just a tool anymore. It's becoming a genuine co-pilot, helping us navigate this incredible complex ocean of knowledge and hopefully speed up discovery itself. Thanks for joining this deep dive.
Thank you. It was great discussing it.